What's up everybody, this is Murteza Kurdi and in this video we're gonna learn what we are going to cover in this chapter. First we are going to learn how a computer works, then we are going to learn about code comments, arithmetic operations, constants and variables. Hey, what's up everybody, this is Murteza Kurdi and in this video I'm gonna talk about how does a computer work. Let's learn about the truth. Okay, so this is a computer. And this computer is simply an idiot machine. It doesn't understand anything until you tell it exactly what to do. So the power of computers really come from the programmers, the people like you and me. For example, if you become a programmer, you can harness the power of computers, because you can tell your computer what to do exactly. So if you want to become a programmer, you should know how does a computer work. So let's go ahead and see what's next. So the first point that I want to talk about here is that at the heart of every computer there is a CPU, as you may already know. The CPU stands for Central Processing Unit. So what is exactly CPU? The CPU is simply a math machine. It works with numbers. A central processing unit simply performs arithmetic operations on numbers, such as subtraction, addition, multiplication, division. All of these operations are performed on numbers by the CPU or the central processing unit. So as a result, when you are operating your computer, this means that your computer is actually crunching the numbers millions of times. So it's all about numbers. So now you might ask that where are these numbers stored? I mean that, yes, we know that the central processing unit is actually working on numbers, but where do these numbers are stored? I mean, how the computer is working on these numbers, and it is actually organized, how the computer organizes these numbers. So now I am going to tell you about something called registers. So the CPU stores these numbers that it operates on in small memory units called registers. This is a small memory unit, and it stores the numbers that the CPU acts upon. So there is a relationship between these numbers and this register. Okay, so hopefully that makes sense so far. So now there is another question. How the computer gets these numbers and put it inside the register? So now we know that the CPU is actually working with numbers. And now we know that these numbers are stored in a small memory unit called register. But how the CPU does this work, how this relationship works? So you might be already familiar with something called RAM in your computer. RAM stands for Random Access Memory. So the CPU or the Central Processing Unit gets these numbers that we have here from the computer's main memory known as RAM or Random Access Memory, and then read these numbers into this small memory unit called register. So let me repeat again. We have something called CPU. The CPU works on numbers. The numbers that it gets from comes from the computer's main memory or the RAM or Random Access Memory. And when it gets these numbers from the computer's main memory, then the CPU can go ahead and read these numbers into something called small memory unit or register. And then it can work on these numbers. Okay, so this is how the relationship works. First we have the CPU, then we have the RAM, and next we have the numbers. So the CPU gets these numbers from the RAM, and then it can go ahead and read these numbers into this small memory unit called register. So I want you to look at this paradigm, I want you to look at this relationship and really understand what's going on behind the scene. So this is how really a computer works. It's just numbers. So now let me talk about another capability of this CPU. This CPU that you can see here can also write the number that is stored inside this register back into RAM. right? So there is also another relationship here. We have something called the register goes to RAM. So why really this relationship exists here? Because in this way, the CPU can work on large amounts of data that wouldn't fit in the register. Remember what I told you about the register? The register is simply a small memory unit. It cannot hold a lot of numbers, and that's why the RAM exists here. The RAM is very important, and that's also why the RAM is called the computer's main memory. Hopefully that makes sense. So now let's take a look at this diagram, and the concept of how the computer works will completely make sense to you. So here we've got the CPU and we've got the RAM. And we know that the CPU has this one called math unit. This is the place that the math operations will take place. And then at the bottom you can see these little small places that are called registers. So these are the registers, the small memory units. We have the math unit and we have the CPU itself. Next we have the RAM, the computer's main memory. The CPU gets the numbers from the RAM. So this is what is going to happen when the CPU gets the number from the RAM and then put it inside the register. Okay. And now the CPU can get this number that is inside the register and then use it inside the math unit, as you can see here. So we have the connection of the RAM to the register, and we also have the connection from the register to the math unit. So here inside the math unit, an operation is going to take place. For example, a multiplication operation is going to take place here inside the math unit. And then the result of that multiplication operation will be stored inside another register. For example, here. So this is how a computer works. And I told you that we can also write a number inside the register to the RAM, like this. So hopefully that makes sense. So what's happening here? So every time an operation is taking place, for example, every time the CPU gets the number from the RAM and then put it inside the register, or for example, when the CPU gets the number and then put it inside the math unit, you can see that these operations are called instructions. So each of them is called instruction. A single instruction is going to take place here when we do something here. So when we say the RAM gives us the number and put it inside the register, this is a single instruction. And when we say, for example, the math unit perform the operation and then put the number inside another register, this is another instruction. So the computer programs that we see every day, they contain thousands to millions of instructions. If you have a Mac OS or a Windows OS, that is a computer program that contains thousands to millions of instructions. And now let me give you some examples. For example, your application is a chat application, and this application allows you to chat with your friend. It allows you to send the current location of the user to another user. It allows you to take a picture and send it to another user. So these are computer programs. These are instructions. We write these instructions in a programming language such as Kotlin or Java. And then another computer program called compiler will convert our code to the instructions that the CPU knows how to understand and execute. So each line of code that we will write in Kotlin will be converted to something that the CPU knows how to execute, and then these codes are instructions that we write. The same instruction will be turned or converted into something that the CPU, the central processing unit, will know how to do or how to execute it. But in terms of Kotlin, for example, here it is a line of code that I write in Kotlin. But we know that in Kotlin, we have something called JVM, right? This JVM is very important here, because now the Kotlin compiler will convert our code into bytecode, and now the bytecode will be run inside an application on the JVM or Java Virtual Machine. And that's how we can see the program running on our computer, right? So let me put the letter P here. That's for program. So we have the Kotlin code, and the Kotlin compiler will convert this code into bytecode. So now the application inside the JVM will run that bytecode, and that's how we can see the results here. This is the result. So by now you should have an idea about how the computers work, and you should also know the importance of numbers by now. So that's what we are going to cover in the next lecture. I look forward to seeing you next. Hi there, so in this video, let's learn about the numbers. We're going to learn how we are representing the numbers in real world, because we know at this point that the numbers are the core of everything when it comes to computers. So first of all, let me tell you that the numbers are the fundamental basis for everything in computers. Whatever info that we send to the computer will eventually turn out to be a number. For example, each character on your keyboard, each letter is represented as a number when it comes to computers. And also, you might say that it's a different story for images, but I'm here to tell you that it's not. The images are also consist of numbers when it comes to computers. So in real world, we have learned about numbers in base 10 system. So now I'm going to give you some information about the base 10 system, and then it will completely make sense. So the reason that I'm going to talk about the base 10 system is that if we are going to watch the world through the eyes of the CPU or the central processing unit, then we have to learn about the base 10 and see how it really works. So assume that I have the number 295. So what does this number mean? This number here means, according to the base 10, that we have 5 units. So I'm going to represent that value here. 9 tens. So I'm going to put the number 10 here above this number 9. And 200s. We have 5 units, 9 tens, and 200s. And each digit of a number can have a value of 0 through 9. So this means that we have 10 possible values for each digit, because it starts from 0 and ends with number 9. For example, here we could have number 0 through 9, here again the same, and here also the same. So we have 10 possible digits that we can use. So we have 10 possible values for each digit. But you know what? The power of each value comes from its position in the number. So moving from right to left, you can see that each digit gets multiplied by an increasing power of 10. So for example, we have number 1, we have 10, and we have number 100. So now let's see what is the multiplier for the far right position, this number 5. So the power of this position is number 10 to the power of 0. So let me show you a calculator. So I told you that the multiplier for the far right position is number 10 to the power of 0. So now let's see the results. The result is number 1. So that's what I told you here about. So as we move on to the left, what do you think is the multiplier for this position? The multiplier for this position is number 10 to the power of 1. Now let's take a look at the Google calculator and let's see the results. So we've got number 10 to the power of 1. Let's see. Now we've got number 10, so here it is, the number 10. And as we move on to another left position here, we have the number 10 to the power of 2. So now let's take a look at the calculator and verify that it's correct. So we have the number 10 to the power of 2. So the result is 100. So this is called the base 10 system. So this is called the base 10 system. And if we had another value here, for example, number 7, so now what do you think about the multiplier for this position? So if we move on to the left again, as we did here, then we have number 10 to the power of 3. So if I show you the calculator, so we have number 10 to the power of 3. The result is 1,000. So here we have this value, 1,000. So hopefully that makes sense. So what does this system exactly mean? What does this number mean here? This means that each digit that we have here has a value 10 times that of the digit to its right. So here it is, the result. We have the number 7 multiplied by 1,000 plus we have the number 2 multiplied by 100 plus we have number 9 multiplied by 10 plus number 5 multiplied by 1, and here it is, the result. So hopefully that makes sense. So in the next video we are going to learn about the binary numbers, and I look forward to seeing you next. And now that you have learned about base 10, it's time to learn about binary numbers, or base 2. So the computers like to work with base 2 rather than base 10 because it's much more simpler than base 10. Remember what I told you about computers. A computer is an idiot machine that likes to work with simple systems. So the computer prefers base 2, and although it might be natural for us to choose base 10 because we have worked with it for so long, the computer likes to work with base 2. So let's see, what is this system? What is the binary number? So the base 2 is called binary. And base 2 has only 2 options for each digit, 0 or 1. And the main reason that the computers prefer the base 2 system is that it needs to only handle 2 options for each digit. So for example, this is a computer, and in digital electronic circuitry, the presence of an electrical voltage is 1 and the absence of an electrical voltage is 0. So this is base 2. So the computers use base 2 because it's much more simpler to handle. So here we've got an electrical voltage, and the presence of an electrical voltage is 1 and the absence of an electrical voltage is 0. So in base 10 number system, the place values increased by a factor of 10. Okay? But what about the base 2? In base 2 number system, the place values increased by a factor of 2. So let me give you some examples. So for example, in base 10, we have number 1, then we have number 10, 100, 1,000, and so on. But what about the base 2? So I told you that in base 2, the place values increased by a factor of 2. So we have number 1, then we have number 2, 4, 8, 16, and so on. So as a rule of thumb, we multiply each digit by an increasing power of the base number. So for example, in base 10, we multiply each digit by an increasing power of 10. But in base 2, we multiply each digit by an increasing power of 2. Okay? This is the rule that you should learn about. So here it is where it gets a little bit interesting. So now you might know that the only numbers that the computer works with is 0 and 1. Okay? So now I'm gonna present a number to the computer. I'm gonna say 1, 0, 1, 1, 0, 1. And now we're gonna start from the far right digit, which is going to be this number 1. The far right digit represents this number 1. And we know that we are going to multiply this digit by an increasing power of 2. Okay, so now let's open our calculator, because now you might know that we are dealing with number 1. So now I'm gonna multiply this number 1 by an increasing power of the base number, which is number 2. So we have number 1 multiplied by 2 to the power of 0. Remember I told you about the increasing power of the base number. So it starts from number 0. So now let's see the result. The result is number 1. And above this number 1, I'm going to draw this number 1 here. This is the result. Next, we have the number 0. Okay, so now we have number 0 multiplied by the base number to the power of 1. So this time it is 1. The power is 1 because I told you that we multiply the digit by an increasing power of the base number. So now we have number 1. Let's see the result. The result is 0. And above this number 0, I'm going to draw number 0 here. Now we have the number 1. So let's go back to the calculator and let's see what's going to be the result. So now we have number 1 multiplied by the base number to the power of 2. Okay? Now let's see the result. It is 4. Let's go back to our digits. I'm going to draw number 4. Now we have the number 1 again. So let's go back to our calculator and let's see what is going to be the result this time. So we have number 1 multiplied by the base number to the power of 3. The result is number 8. Okay, so let's go back to our digits and this time we have the number 8 above this number 1. Now we have the number 0. So this time I'm gonna multiply the number 0 by the base number, which is number 2, to the power of 4. The result is number 0. So now I'm gonna draw the number 0 above this number 0 that we have here. Okay, and finally we have this number 1. So number 1 multiplied by the base number to the power of 5. The result is 32. So I'm gonna draw the 32 here above this number 1. So this is how the base 2 works. So let's take a look at this pattern again. There is something interesting here. You can see that every power of 2 that is actually a 1 or is not a 0 is presented as a component of a binary number. So for example, this 32, 8, 4, 1, it's a component of a binary number. Hopefully that makes sense. So finally, before I finish this video, let's learn about the decimal version of a binary number. So the decimal version of a binary number is the sum of all the powers of 2 that make up this number. So here we have 32 plus 0 plus 8 plus 4 plus 0 again plus 1. The result is going to be the decimal version of this binary number. The result is going to be the decimal version of this binary number. So it's 45. This is the result. In the next video, we're gonna learn how to convert a base 10 number to a base 2 or binary number. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi and in this video we're gonna learn more about binary numbers. Okay, so here we have a binary number. And first let me tell you that each digit of a binary number is called bit, a contraction of binary digit. So that's why it is called bit. So 8 bits is called 1 byte and 4 bits is called 1 nibble. So here let's take a look at our CPU again. So here it is the CPU, we have the math unit, we have the registers. Now I want to talk about the computer's memory because the computer's memory is limited to a certain length. For example, these registers can either be 32 bits or 64 bits in length. And that's why we have 32 bits or 64-bit CPUs. So the 32-bit CPU can handle 32 ones as the base 2 number. And what about the 64-bit CPU? The 64-bit CPU can handle 64 ones as the base 2 number. So here we've got 32 ones. If you want to, you can count them. And this means that a 32-bit CPU can handle the maximum number of 32 ones as the base 2 number. And a 64-bit CPU can handle 64 ones as the base 2 number. And now you might ask that is it possible for a CPU to handle numbers larger than the maximum value that it can handle? And the answer is yes. But the calculations must be split up in a special and managed way, so the CPU will actually be able to handle these large numbers and calculations. In the next tutorial, we are going to learn about hexadecimal numbers, and I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kordi, and in this tutorial, we are going to learn how to convert a base 10 number to base 2. So in order to convert a base 10 number into a base 2 number, we just need to break down the base 10 number into its component powers of 2. So let me give you an example so that it will completely make sense. So for example, we have number 728. And I want to convert this number to a base 2 number. How can I do that? So now let me bring up the calculator. We have number 728 divided by 2. Let's see the result. The result is going to be 364. But this is not the binary number that we are looking for. How can I find the binary number? In order to do that, we need to take a look at the remainder value of this division operation. So if I divide the number 728 by 2, the remainder value of this division operation will be 0. How can I say that? Because take a look at the number at the far right position. It is number 8. The number 8 is an even number. So I'm sure if I divide the 728 by 2, the remainder value will be 0. But if the number at the far right position is an odd number, and if I divide this value by 2, the remainder value will be number 1. Okay, so now let's specify the first binary number. I'm gonna start from right to left. The order is going to be from right to left. So now let's take a look at our calculator. And now we have number 364. Let's divide this number by 2 and see the result. The result is 182. But the number 364 divided by 2, I know that the remainder value of this operation will be again 0. So I'm gonna specify this remainder value here, 0 again. And now we have number 182. So the number 182 divided by 2, again the remainder value of this operation will be 0. Why? Because the number at the far right position is an even number. So again we have number 0 here. So now let's divide this number by 2 and let's see the result. Now we have number 91. Okay, now the number at the far right position is not an even number, it is actually an odd number. So if I divide the number 91 by 2, I know that the remainder value of this operation will be 1. Okay, so let's divide the number 91 by 2 and let's see the result. We have number 45.5. So let's completely ignore the decimal value after the decimal point. We have number 45. So the number 45, again, you know that the number at the far right position is actually an odd number. So if I divide the number 45 by 2, the remainder value will be number 1 as the binary number. So let's divide this number by 2 and let's see the result. We have number 22. So again, let's completely ignore the decimal value. We have number 22. So the number 22 divided by 2, the remainder value will be 0 because the number at the far right position is an even number. So I'm gonna draw the number 0 here as the binary number. So let's divide this value by 2. The result is 11. So you know that the number at the far right position is an odd number. So if I divide this number by 2, the remainder will be the number 1. So let me draw the number 1 here as the binary number. Now let's divide this number by 2. It is going to be number 5. So if I divide the number 5 by 2, the remainder value will be 1. So I'm gonna draw the number 1 here as the binary number. So now let's divide this value by 2. The result is number 2. And now if I divide the number 2 by 2, the remainder value will be 0. So the binary value is actually 0. So let me divide this value by 2. Now we have number 1. So again, if I divide the number 1 by 2, the remainder value will be 1. So this means that the binary number is actually 1. So let me just draw the number 1 here as the binary number. So now you can see that here it is the base 10 number, and here we have converted this base 10 number to a base 2 number that only consists of 0 and 1. That's it. So in the next video, we are going to learn more about binary numbers. I look forward to seeing you next. Hi there, so now that you have learned about binary numbers, it's time to learn about hexadecimal numbers or hex. So now let me give you some points about using the binary numbers and its disadvantages. First of all, working with binary numbers is quite tedious because it takes a long time to write or type them. So because of this specific reason, in computer programming, we need to use another number format named as hexadecimal or hex. And hexadecimal or hex is actually base 16. So first, let me clarify something for you. There aren't 16 distinct numbers for digits. And there are only 10 distinct numbers, 0 through 9. And now you might ask that, okay, we are dealing with a base 16 and we have only 10 distinct numbers. So what about the 6 remaining numbers? So in order to solve this problem, we use the first 6 letters of alphabet A through F. So these 6 letters are equivalent to decimal numbers. So these 6 letters are equivalent to decimal numbers. So A is equal to 10, B is equal to 11, C is equal to 12, and so on. Okay, so now let's take a look at an example to see how the base 16 works in real world. Okay, let's take a look at this example now. So here we've got this hexadecimal number A, 8, F, 2. And the values of each digit refers to powers of 16. So here we've got number 1 multiplied by 16. And then we've got number 16 multiplied by 16. Then we have the result 256. Then we've got 256 multiplied by 16. Then this is the result, 4096. So now how we can decode this hexadecimal number? So you know that the letter A is actually number 10, right? So in this way, we just need to put a pair of parentheses. And I've got number 10 multiplied by 4096. And now let me close this parenthesis, plus, then we have this number 8. So we have another pair of parentheses. We have number 8 multiplied by 256. And then we have this letter F. So the letter F is actually number 15. So we have a pair of parentheses again, number 15 multiplied by 16, and then we close this parenthesis, plus, then we have number 2 multiplied by number 1. The result of this operation will be the decimal value. So in order to calculate this operation, first I calculated the operations inside the parenthesis, and then here I am adding these values together. The result is 41714. And now you might ask that why we should use hexadecimal numbers. What are the advantages of hexadecimal numbers over the other number formats? The hexadecimal number is more compact and clear over the other number formats such as the decimal or base 2. Each hexadecimal digit can exactly represent 4 binary digits. The binary number 1111 is equivalent to hexadecimal F. So what does this exactly mean? We can easily concatenate the binary digits representing each hexadecimal digit, creating a hexadecimal number that is more compact and shorter than its decimal or binary equivalents. So in the next video, we're gonna learn how the code works in programming. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial, we are going to learn how the code works. So first, let me tell you that the computers are not that smart as you may think, because the computers can only do some very small things, and we as the computer programmers can really bring up the real power of the computers to the surface by putting those small things that a computer can do in the right order in order to create something bigger. Writing code or programming is like writing a recipe. For example, when you are writing a recipe, you refer to the ingredients, right? So in case of computer programming, the ingredients of computer programming is called data. We are dealing with a lot of data, and we need to know how to put this data in the right order in order to create something that we really want. So the process of programming or writing code is actually first specifying the ingredients or data that we are going to work with, and then providing the computer with a step-by-step recipe in order to use the ingredients or data. So let me give you an example about a recipe or pseudocode. For example, we want to create a Tinder clone application. First of all, we need to handle the sign up or sign in process. The second step is to show the nearby people to the current user of the application. The third step is to allow the current user of the application to like the other people. And finally, we need to set up the matches so that the users can chat with each other. So this is an algorithm for a dating application. You can see that it is not written in a valid programming language. It is just a recipe or pseudocode so that we have an idea when we want to create our application. This pseudocode is about the steps that should be executed so that we have a complete application. And as we are going to write Kotlin code, we are going to follow the same process. We are going to provide the computer with a step-by-step instructions so that the computer will execute whatever we tell it to do. We simply let the computer know what we want to be done one step at a time. So here it is the idea. We are going to write code or Kotlin code. Then the compiler is going to interpret our code and convert it into instructions that the CPU can execute. In the next video, we're gonna go ahead and start coding in Kotlin. So let's get started. Hey, what's up everybody? This is Morteza Kordi, and in this tutorial we are going to learn about comments in programming. First of all, comments allow you to document your code. So as a result, by using comments and documenting your code will be more understandable to others or maybe yourself. Later, when you want to take a look at your code, you will understand what you have done before. And another great advantage of writing comments is that the compiler will completely ignore your comments, so you can write whatever text you want. So now let's learn about the types of comments. The first type that you are going to learn about is called the single line comment. And we have also another type of comment called multi-line comment. A multi-line comment starts with a slash and a star and ends with a star and slash. And now let's go ahead and open our IntelliJ IDEA IDE, and I want to show you how to write comments in programming. So open your WhatsApp Kotlin project, or if you want to, you can create a new project. And sometimes when you open your project in Kotlin, you will see a message like this at the bottom right corner that says that there is a new update to the Kotlin plugin. If you want to, you can install the plugin by clicking on the install. So when you open your project, make sure to open the project view and then go to src or source and make sure to open the WhatsApp Kotlin file. Or if you are creating a new project, make sure to create a new file, new Kotlin file actually, named as WhatsApp Kotlin. So here inside this file you can write comments wherever you want. But let's go inside the curly braces of this main function. So here it is, the opening curly brace followed by a closing curly brace. Here I'm gonna write a single line comment. So I just need to put 2 slashes, and this is my single line comment. And in order to create a multi-line comment, I need to start my comment by slash star, and then I can type whatever I want. And then in order to end this comment, I need to put star slash. So what's the difference between single line comment and multi-line comment? In multi-line comment, I can write multiple lines of comments, as you can see here. But a single line comment, we cannot extend this comment to some other lines of comments. So hopefully that makes sense. And as I said earlier, we use comments in order to document our code. So here we have one line of code, this println statement. So here, before this line of code, I can create a single line comment and say that here I am printing something to the console. So later, when someone else is looking at my code, they can understand what's going on here. And the final point that I want to talk about here is that in Kotlin, unlike other programming languages, we can have nested comments. So for example, take a look at this multi-line comment here. Inside this multi-line comment, I can have another multi-line comment. So here, I can start a new multi-line comment by putting a slash and star, and then I can end it with a star and slash. So you can see that I can put another comment here. In other programming languages, it is not allowed to have a nested comment. So that's another great advantage of Kotlin. So in the next video, we're gonna learn about printing out in Kotlin. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial, we are going to learn about printing out in Kotlin. Okay, go ahead and open your What's Up Kotlin project. And then here you should have the main function. Remember what I told you about this function? This function is the starting point of our application. So if you want to see the results of your code, you should put your code inside this function. Okay, now I'm gonna print my name to the console. So I'm gonna say println. This is the statement that you should use. And then go inside the parentheses of this statement and put 2 double quotes. Inside the double quotes, just enter your name. So now in order to run this file, I just need to click on this play button just inside this gray area on the left sidebar. Click on Run What's Up Kotlin file. Here it is, my name printed out here. So how do I open and close this console area? At the bottom left corner, you can see this area called Run. Number 4:Run. So if I click on it, now it is collapsed. And if I click on it again, now it is opened. So this is the console area. In the next video, we are going to learn about arithmetic operations. So I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial, we are going to learn about arithmetic operations. So now let me talk a little bit about the operations. For example, when we take one or more pieces of data and turn them into another piece of data, this is called an operation. So for example, we have one piece of data here, we have another piece of data here, and when we take these 2 pieces of data and turn them into another piece of data, like this one, then this process is called an operation. So now let me give you some examples. For example, the addition operation takes 2 numbers and converts them into the sum of the 2 numbers. So we have number 2 plus number 2, the result is number 4. This is an operation. So for example, we have number 10 minus 5. The result is 5. So here we've got the subtraction operation that takes 2 numbers and converts them into the difference of these 2 numbers. And we have also the arithmetic operations in most of the apps. For example, the Instagram app has something called the number of likes. The number of likes that a post gets. So it's an arithmetic operation. Or for example, the number of comments that a post gets, or the number of views that a video gets, right? These are the arithmetic operations that we see in most of the applications. These are actually simple arithmetic operations. So in the next video, we're gonna learn about simple operations in Kotlin or programming. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial we are going to learn about simple operations. So all of the operations that we see in programming use a symbol to specify the type of operation they perform. So we have 4 simple operations. We have the multiplication operation, we have the division operation, we have the addition operation, and we have the subtraction operation. So for example, 5 multiplied by 2. The result is 10. Or we have number 100 divided by 10. The result is 10, right? The result is again 10. And for the addition operation, we have number 5 plus 5. And for the subtraction operation, we have number 20 minus 10. So each of these operations that you can see here, for example, this one, 5 multiplied by 2, is called an expression. An expression in programming has value. This is very important. So for example, 5 multiplied by 2, the value of this expression is 10. Or take a look at this one, number 100 divided by 10. So again, this is an expression that has a value. 100 divided by 10 has a value that is actually 10. Number 5 plus 5, again, another expression. So this expression has a value, and the value is 10. Or this one, number 20 minus 10. Again, another expression that its value is 10. So now go ahead and open your WhatsApp Kotlin project. Let's go inside the main function and let's create some operations here. So println, the first operation is going to be the multiplication operation. Number 5 multiplied by 2. So now let's run the app and see the result. In order to run the app, you just need to click on this play button just beside this main function inside this gray area. So inside the console area, you can see this number 10. Okay, let's move on to the next operation, which is going to be the division operation. So number 100 divided by 10. So notice how I am writing my code. So we have number 5 space multiplication operation space number 2. So in this way, it is more readable. Okay. If you delete this space here, you can see now it is less readable. So in order to make your code readable, always add spaces. For example, here, here, and here. It's much more nicer and beautiful. So let's run the app and see the results. The next operation is the addition operation. So we have number 5 plus number 5. Okay, if I run the app, again, we should see number 10 as the result. And the final operation is actually the subtraction operation, number 20 minus 10. The result is 10 again. So in the next video, we are going to learn about decimal numbers. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial, we are going to learn about decimal numbers. So in the previous video, we worked with whole numbers or integer numbers. But now we want to learn about decimal numbers in programming. So for example, if I divide number 5 by 2, what do you think is going to be the result? Because I am dividing a whole number or an integer number by another whole number, the result is going to be another whole number. Okay? This is not going to be 2.5. That's not the case here, because in Kotlin or in programming, when we implement an operation on two integer numbers, the result is also going to be an integer or whole number. If I want to see the result as a decimal number, in that case, I should say 5.0 divided by 2.0 divided by 2.0. Now I am going to see the result as number 2.5. Okay? And you can also have only one number to be a decimal number in order to see the result as a decimal number. So here, for example, I can easily specify that number 5, which is going to be a decimal number, divided by the number 2, which is actually a whole number. In this case, the Kotlin is also going to give you the result as the decimal number, so 2.5. Now let's go into our IntelliJ IDEA and see the results in code. Okay, so now I'm gonna say println 5 divided by 2. Let's see the result. Here we've got number 2 outputted to the console. Okay, so now I'm gonna say println 5 2.0. So now I am converting my integer number to a decimal number by putting this dot and 0 and then dividing it by 2.0. Let's see the result now. So now it is 2.5, and then I am going to divide number 5.0 by 2. The result again is going to be 2.5, as you can see here. So hopefully that makes sense. So in the next video, we are going to learn about the remainder operation. I look forward to seeing you next. Hey, what's up everybody? This is Murtaza Kurdi, and in this tutorial we are going to learn about the remainder operation. In division, the denominator goes into numerator a whole number of times plus a remainder. For example, number 5 divided by 2. Here, the numerator is number 5 and the denominator is number 2. And here, number 2 goes into number 5 a whole number of times plus a remainder. So in this specific operation, the remainder value is going to be number 1. That's it. In Kotlin, the modulo operator or the remainder operator is represented as the percent operator. So we use this percent operator in order to calculate the remainder of two numbers. So for example, if we have number 7, okay, and we use this percent operator and we put number 2 here, so here the number 2 goes into number 7 3 times with the remainder of 1. So the remainder is 1. Hopefully that makes sense. Now let's go into code and see how it is done. Okay, so we have println number 20 percent operator 15. So here the denominator number 15 goes into number 20 only once with the remainder of 5. So now if I run the app, we should see number 5 as the result here. Okay, so for example, if I say println number 5 percent operator or modulo operator. Okay, let's see another example. So println number 5 modulo operator 3. It goes into the numerator, which is going to be number 5 only once. So the remainder value is going to be number 2. Let's see the result. Hopefully that makes sense. So if I have decimal numbers, again, we can see the result here. So I can say println number 15.0 modulo operator 4. So in that case, let's run the app and let's see the result. So we've got number 3 as the remainder. So in the next video, we are going to learn about the shift operations. I look forward to seeing you next. Hi there, in this video we are going to learn about the shift operations. So we've got the shift left operation and we've got the shift right operation. The shift left or shift right operations take the binary form of a decimal number and shift the digits left or right respectively. So here it is what the shift operations exactly do. For example, we've got number 48 here. It is a decimal number. So the shift operation is going to access the binary number of this decimal number. It's going to convert this decimal number to a binary number, and then it's going to shift the digits left or right respectively. Now let me give you a real world example. So for example, here it is the binary form of a decimal number, and I want to shift the digits to the left by 3. So in that case, let's see what is going to happen. If I shift the digits to the left by 3, then we are going to have this number 0 here, this one also here, and here, right? We are shifting the digits to the left by 3. So what is going to remain? We are going to have this number 0 here. So I'm going to put it here. Then we are going to have this number 1 that we get here, then another number 1 that we get from here, and this number 0 that we get from here. And so you might know that the digits that are shifted to the left are actually gone. So we do not put these numbers anywhere. It's going to be gone. They are actually deleted. So now what happens to the other digits, to the other empty areas? So we are going to have free empty areas. Why? Because we shifted the digits to the left by 3. So now we are going to have free empty digits here. So in other words, the digits that fall off the end on the left are lost. Okay? The digits that fall off the end on the left are lost. And here, the empty digits that we are going to have here is going to be 0. So this is the shift left operation. We also have the shift right operation. That is going to be the opposite of the exact operation that we did here. That is going to be the exact opposite of the operation that we implemented here. So shifting right is the same, but the digits move to the right instead of to the left. So what happens after this shift operation? Then the shift operation, so for example in this case the shift left operation is going to return the decimal form of this binary number. And we are going to use the shift left operation, for example. So in that case, it's gonna get the binary form of that decimal number. After the operation is implemented and finished, it's gonna return the decimal form of that binary number. So now let's go into code and see how it is implemented. Okay, so I'm gonna type in here println. So the number that I want to use is 25. I am going to use the shift left operation. So SHL is shift left and SH right is shift right. So let's choose this one, SHL. So now we need to specify the bit count. So for example, I want to shift the number 25 to the left by 2. So I want to put the number 2 here. Let's see the result. So here it is going to output the number 100 to the console. So what happened here? First, the number 25 is a decimal number. So now the shift left operation is going to take the binary form of this decimal number, number 25, and then it's gonna shift the digits to the left by 2, and then it's gonna return the decimal form of this binary number, of that result. So the decimal form is number 100. Okay? So let's see another example. This time I want to use the shift right operation. For example, number 37, shift right, and this time I'm going to use number 7. Let's see the result. So we've got number 0 here. So let me change number 7 to number 2, and this time let's see the result. Now we've got number 9. So now you might ask that what is the use of this shift operation? Why we should learn it? So the first benefit of using the shift operations is that the multiplying or dividing by powers of 2 becomes fairly easy. So what does that mean? So for example, shifting left by 1 is the same as multiplying by 2. Okay? Or shifting left by 2 is the same as multiplying by 4. Or shifting left by 3 is the same as multiplying by 8, and so on. Or for example, shifting right by 1 is the same as dividing by 2. Or shifting right by 2 is the same as dividing by 4. Or shifting right by 3 is the same as dividing by 8, and so on. So now let's go back to code. Here you can see that when I said 25 shift to the left by 2, what does this mean? This means multiply 25 by 4. Okay, the same rule that I showed you here. Shifting left by 2 means multiplying by 4. So here you can see that I am saying 25 shift left by 2. This means multiply the number 25 by 4. That's why you can see number 100 here. Or we have number 37 here. I am saying that 37 shift right by 2. So this means number 37 should be divided by 4. So 37 divided by 4 is going to result the number 9. Hopefully that makes sense. So in the old days, the CPU was comfortable using the shifting operations rather than the complex operations such as the multiplication or division operation. So that's why in the old days, this trick, these shifting operations were very famous, and the code was very quicker because of the shifting operations. But nowadays, the CPUs are much more faster and powerful, and compilers can convert multiplication and division by powers of 2 into shifts for us automatically. So in the next tutorial, we are going to learn about operator precedence. I look forward to seeing you next. Hey, what's up everybody? This is Murtaza Kurdi, and in this tutorial, we are going to learn about operator precedence in programming. So first, you should know that the parenthesis has higher precedence than the multiplication operator and the division operator. And the multiplication operator and the division operator has higher precedence than the plus and minus operator. So here you should know that the multiply and division operator have the same precedence, and these two operators have higher precedence than the plus and the minus operator. So these two operators, plus and the minus operator, have again the same precedence. So now let's go into code, and I'm going to show you some real world examples. Okay, so here I can say println, and then inside the parentheses I'm going to put another pair of parentheses. So let's say 5 multiplied by 4, and then after this parenthesis I'm gonna use the plus operator, and then we have number 20 minus 5 multiplied by 9 plus 2 divided by 4. So let's see how this operation is going to be executed, how the operator precedence is going to affect this operation. So first, let me tell you that the operation inside the parentheses is going to be executed first. So first, we are going to have number 5 multiplied by 4. So you know that the multiplication operator and the division operator have the same precedence, and these two operators have greater precedence over the plus and the minus operators. So the next operation that is going to be executed is going to be number 5 multiplied by 9. So here we have number 5 multiplied by 9. Then we have a division operator, right? So number 2 divided by 4. Now it's gonna execute the other operations. So for example, after the number 5 is multiplied by 9 and the number 2 is divided by 4, then it's gonna go ahead and execute the plus operation and the subtraction operation. Okay, now let's go ahead and calculate this operation. First of all, number 5 multiplied by 4, the result is number 20. Remember, the multiplication operator has higher precedence than the plus and the subtraction operators. So this operation here is going to be executed first. Number 5 multiplied by 9, the result is 45. Then we have this operation, 2 divided by 4. So the result of this operation is going to be 0.5, but because here we are dealing with integer numbers, the decimal value after the decimal point is going to be eliminated. So the result is going to be 0. Now that we have the result of this operation to be 20, then we can go ahead and simplify this operation. So we have number 20, okay, plus number 20 minus 45. Next, we have this operation, 2 divided by 4, the result is 0. So it is going to be plus 0. Okay, so 20 plus 20 is 40 minus 45. We are going to have minus 5 or negative 5 as the result. Let's go ahead and run the application and see the result. So as soon as I hit the run button, it's showing us an error, and it says that there is an error here. We have a compile error, so I'm gonna comment out this line of code so that the compiler will be satisfied. Let's go ahead and run our application. So now you should see the value negative 5 or minus 5 as the result outputted to the console. So remember that the order of operations is from left to right. So here we have the addition operation, then we have the subtraction, and then we have the plus. Okay, It is from left to right. Hopefully that makes sense. So in the next tutorial, we are going to learn about math functions in Kotlin. So I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial we are going to learn about math functions in Kotlin. So first let me tell you that Kotlin has a vast range of math functions in its standard library, and we can use these functions in our code whenever we want. So let's go into the IntelliJ IDEA IDE and let's see some real-world examples. So in mathematics, we have a number called pi. So in Kotlin, we can access the value of the pi number by just putting the capital P and capital I. So when I do that, you can see that here it is showing us the Kotlin.math package. So it is going to be a value of type double, right? If I select this number, at the top of the file, notice what happened. We have this statement, this import statement. It says import kotlin.math.py. So let's go ahead and run our application and see what happens. So let's see what is outputted to the console. Here it is, the number 3.14. So this is the pi number, right? So this is exactly the pi number. In mathematics, we might have only seen the 3.14, but this is the exact number. So remember, the computer is very precise. So it is showing us the exact pi number. So now let's go back to our main method, and I'm gonna comment out this line of code. So now I want to calculate the sign of a number. So here I just need to say println, and inside the parentheses, I can enter the sign function. So it is going to be sign, and inside the parentheses of the sign function, let's say 3 multiplied by the pi number divided by 4 plus 7. So the operation inside the sign parentheses is going to be executed first, and then it's going to give us the sign of the result of this operation. Okay? So now let's go ahead and run our application and see the results. So here in the console, you can see this value. And by the way, if you are not familiar with these math functions, don't worry. I'm just showing you the math functions that are available to us that we get from the Kotlin.math package, from the standard library, okay? You can also use some other functions. You can search online for the Kotlin standard library and see all the math functions that are available to us. I'm just showing you some instances that might be helpful to you in the future. So the next math function that I want to talk about here is the cosine function. So inside the parentheses of the println statement, I'm going to say cosine, and then inside the parentheses of this cosine function, I can enter the number. For example, number 45. So here you can see that it's showing us an error. It says the integer literal does not conform to the expected type double. So this cosine function does not expect a value of type integer. So we need to convert it to a double value by just putting dot 0. Okay, let's go ahead and run our app. So here it is, the value of this cosine function outputted to the console. So now let's go ahead and learn about the square root function. So we can also get the square root function. So we can also get the square root of a number. We have a function for that. So let's say println, and inside the parentheses, I'm gonna say square root sqrt, and then I can enter the number 4, for example. So again, it is going to be of type double, so 0.0. Let's run the app. So the square root of number 4 is number 2.0. I can also get the maximum or the minimum value of two numbers. So here I can say println, and then I can say max. So for example, I can enter number 10, 20. So this function is going to return the maximum value of these two numbers that we put here, that we entered as an input. So let's go and run the app. Obviously, it is going to output the number 20 to the console. Okay, so let's get the minimum value of two numbers. So again, I'm going to use another function, another math function that is called min, and this time I'm going to enter number 100 and 400. So let's see the result. And also, if you want to, you can combine these math functions together. So take a look at this statement, println. So I want to get the maximum number here. So the first value is the number pi multiplied by square root of 8, and the second number is square root of 90. Let's run the app and let's see the result. But first, let me comment out these lines of code here. Okay, so here it is the result. Here it is the maximum number that we get from this math function. Hopefully that makes sense. So in the next video, we are going to learn about the naming data. I look forward to seeing you in the next tutorial. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial, we are going to learn about naming data in programming. So first, let me tell you that computer programming is all about manipulating data. Remember what I told you earlier about numbers and computers? Everything you see on your computer is all about numbers. Everything is converted to numbers, and the computer can only understand numbers. Everything. So sometimes there are different forms of data. For example, we are working with text, we are working with images or collections. All of these forms of data will finally be converted to numbers so that the computer can handle them. But we as the programmers, we need to handle these kinds of data. So now you might ask that what's the point here? So sometimes we're dealing with a specific kind of data, such as text. And we need to refer to this text later in our code. How we can do that? First, we need to give this text or this data a name. The reason that we are giving this text or this data a name is that we can refer to this data later by just accessing its name. So later in our code, for example here, when I say name, then we are referring to this name of this data, right? So this means that we are actually referring to this data. This name is just an identifier that is going to help us to access this data. And now you might notice that this data has a type. So the type determines what sort of data this name refers to. So for example, if the type of our data is integer, then this name is referring to an integer value. Or if this type is actually text, then this name is referring to a text value. So every kind of data has a name and a type. So in the next tutorial, we are going to learn about constants in Kotlin. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this video, we are going to learn about constants in Kotlin. So in order to create a constant, we use the keyword val. So next, we need to give our constant a name. So I'm gonna name it as my name. So notice how I am naming my constant. It is called camel case. So the first letter of the name starts with a lowercase letter, and the subsequent words after the first word is started with a capital letter. Okay, so this is called camel case that we use in order to give our variables or constants a name. So just keep that in mind. So next we have something called an assignment operator. So in programming, this is not called an equal operator, it is called assignment operator. Okay, after the assignment operator, we are going to assign a value to this variable. So for example, I'm gonna put m.k. So this is the name that I am assigning to this constant. So first, we have the val keyword, then we have the name of this constant, then we have the assignment operator, and then we have the actual value that we are assigning to this constant. So what does this mean? This assignment operator means that we are assigning whatever value that we have on the right side of this operator to the left side of this operator. So in this case, we are assigning m.k to this my name constant. And finally, a constant can also have a type, or in other words, all constants have a type. So here in this case, the type, so I'm gonna just put the type here because there is no space here. I'm gonna say the type is string. So this means that the constant named as my name can only accept values of type string, and the values that are of type string are put inside the double quotes. So I'm gonna put 2 double quotes here so that this value m.k is inside the double quotes, and now it is considered as a string value. In Kotlin, we can have variables that don't have a type. So in that case, the compiler is going to infer the type of your constant from the value that we assign to our constant. So for example, in this case, if we don't specify the type of our constant, the compiler is going to take a look at the value that we assign to this constant, and it's going to specify the type of this constant. But I'll talk more about that later. For now, don't worry about the inferred types. We're not dealing with the inferred types now. We just want to learn about constants. So now let me give you another example. So in order to create a constant, first we need to use the keyword val, okay? Then we need to give our constant name. So I gave it the name laptop RAM. Then we need to specify the type of our constant. So I'm going to put a colon here. So the type is going to be integer. Assignment operator. So I'm going to assign the value 16 as the value of this constant. So we have the val keyword, the name of the constant, the type, assignment operator, and the value that we assign to this constant. So this constant is the same as the previous constant that we created earlier, but this time the name and the type is different. So now let's go into code and see some real-world examples. So inside the main function, I'm gonna say val, and the name is going to be my pi number, and I'm gonna set the type to be double. So the double is used to store decimals in a constant. This is the type double. I'm gonna put an assignment operator, and I'm gonna use the value 3.14. Okay, so now if I want to output this value to the console, I just need to say println my pi number. Remember, this name is an identifier that I can use in order to access the value that we assigned to this constant. So when I say println my pi number, I want to actually output this value to the console. So let's go ahead and run our app and see what happens. So in the console, you can see this value 3.14. So the double type is used to store decimals with high precision. We have another type named as float. So let me create another constant, val, and I'm gonna name it as price. This time the type is going to be float. Assignment operator, and I'm gonna assign the value 2.7 to this constant. But notice what happens. When I do that, it's showing us an error, and it says that the floating point literal does not conform to the expected type float. So the compiler thinks that I am assigning a value of type double to this constant. So in order to solve this problem, I just need to put the letter F after this value. So now the compiler is satisfied now that I'm assigning a value of type float to this constant, which is of type float. So what's the difference between float and double? So the float data type is used to store decimals with lower precision than double. And the double data type has about the double precision than float. And the double data type has about the double precision of float. And that's why it is actually called double. And the double data type has about the double precision of float. And that's why it is actually called double. And the float data type takes less memory than double. So that's an advantage of using float. But nowadays, CPUs are really powerful and the memory usage of numbers is not that important. But I, as the programmer and a teacher in this field, suggest you to always consider the memory if you want to have high quality applications. With that said, you will always see the double used for storing decimal values. Okay, so another important point that I want to talk about constants is that once we declare a constant, we cannot change its value later. So for example, here I cannot say my pi number assignment operator 2.7. That's not possible. Why? If I hover over the error area, it says val cannot be reassigned. Or for example, I cannot say the value price to be changed to another value, for example 1.5. Again, it's showing us an error, and if I hover over this error area, it says that the val cannot be reassigned. So these two lines of code cannot be compiled, so that's wrong. So first you should know that once you declare a constant, you cannot change its value later. We have another type of constant in Kotlin that is called compile time constant. The compile time constant is declared outside of any functions. So outside of this main function, I can say const val. And then I can give this constant a name. For example, I can say my name, assignment operator. So this time I want to specify the data type of this constant to be string, and I'm gonna put two double quotes and I'm gonna assign my name to this constant. So this constant is called compile time constant. We'll learn about these types of constants later in this course, but for now just know that this type of constant is declared outside of any functions and it is called compile time constant. If you declare this type of constant, you must initialize it. So if I delete the value of this constant here, and now if I hover over this constant, it says property must be initialized. But here, if I go inside this main function and delete the value here, you can see that it is not require me to initialize this function. In line number 9, where I'm actually trying to print out this value, this constant to the console, it says that the variable must be initialized. But if I comment out this line of code, now you can see that the compiler is not complaining about not initializing this myPy number constant. So that's another difference between compile time constant and the usual constant that we have here. So in the next tutorial, we are going to learn about variables in Kotlin. I look forward to seeing you next. Hey, what's up everybody? This is Murtaza Kurdi, and in this tutorial, we are going to learn about variables in Kotlin. So sometimes a person needs to keep track of something that is going to change. For example, we have a pet, right? And we want to keep track of the age of this pet. So we have a variable called age, and we need to keep track of it. In that case, we do not use a constant. Why? Because we cannot change the value of a constant once it is initialized. In this specific case, we are going to use a variable so we can change the value of it later if we want to. So let me create a variable for this age of this pet. So we have something called var. In Kotlin, we use the var keyword in order to create a variable. Then we need to give this variable a name. So it is going to be pet age. So I'm gonna specify the type to be integer, so int, and then we use assignment operator, and then here I'm gonna set it as number 15. But 1 year later, then we can change the value of this variable pet age to be 16. So that's the difference between variables and constants. So if you create a constant and initialize it, you cannot change its value later. But if you create a variable and initialize it, you can change its variable later. So variables are useful if you want to keep track of something that is going to change in the future. For example, you want to keep track of your bank account balance. So in that case, you should not use constant, you should use a variable so you can change the value of your variable later. So remember, we use a variable or a constant in order to represent our data. So if we are representing our bank account balance, it should be something that we can change later. It should not be a constant, otherwise it will be a boring program. So now let's get into code and see some real-world examples. Okay, so now let's go inside this main function, and I'm gonna use the var keyword and I'm gonna name it as my age. So let's set the type to be integer. I'm gonna put an assignment operator and I'm gonna assign the value, for example, 25. So now imagine 1 year is passed and I can now change the value of this variable to 26. Okay, another year is passed and I can change the value of this variable to 27. So first let me tell you that the flow of the program is from top to bottom. So when the flow of the program enters into this main function, which is going to be the starting point of our application, first it is going to execute this line of code in line number 5, then this one, and then this one, okay? Line number 10. So this is how the program is going to be executed from top to bottom. So for example, in line number 6, after assigning the value 25 to my variable, I can say println my age, right? And then after assigning 26 to my variable, I can say println my age. And finally, after assigning the value 27 to my variable, I can say println my age. So that's it. So now let's go ahead and run our application and let's see the results. So in the console, we have number 25, 26, and 27. So you can see the difference between a constant and a variable is that when we create a variable, we use the var keyword instead of val. And here it is the name, again the same as the constant. We also specify the type, so again the same as the constant. And here it is the value. So the only difference is that we use the var keyword instead of val, and when we create a variable, we can also change its value later if we want to. Okay? So if you want to represent a data that is going to change later, you should use a variable instead of a constant. Hopefully that makes sense. So as the final point, I'm gonna tell you about representing large numbers. So let's create a variable and let's say that the name of this variable is my bank account balance. And then I'm gonna specify the type to be integer, assignment operator. So I'm gonna enter, or I'm gonna assign the value 1 million to this variable. So I can say 1, 0, 0, 0, 0, 0, 0. So you can see it's not that human readable to specify our data like this. If you want to make it more human readable, you can use a symbol called underscore. So here I can use a underscore here and here. And now you can see that it's more human readable and the compiler doesn't have any problem with writing our number like this. So it doesn't matter where you put the underscore as long as it's readable. So now if I try to output the value of my variable to the console, my bank account balance, so let's run the app, you should see that it's gonna output this value to the console, but without the underscores. So it's a trick in order to represent large numbers in a more human readable manner. Hopefully that makes sense. So in the next tutorial, we are going to learn about meaningful naming in Kotlin. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kordi, and in this tutorial we are going to learn about meaningful naming in programming. So in programming, if you want to represent your data as a variable or constant, it's very important to specify the names of your variables to be readable. If the names of your variables or constants are not readable, in that case we are going to have problems. Or if you want to send your code to someone else to look at your code, they won't understand what does your code mean. They won't understand what is this variable doing. They can't understand what you are trying to do in your program. So choosing readable names for your variables or constants in order to represent your data is crucial. So for example, let me give you some examples about good names. So if you want to represent the name of your pet in a program, I can say pet name. So notice how I am using camel case in order to specify the name. The first word starts with a lowercase letter, and the subsequent words after the first word starts with a capital letter. Okay? So this is how the camel case naming works. So this name is a good name in order to represent the name of our pet. So now let me give you a bad example in order to represent the name of our pet. The bad example would be, for example, choosing only one letter. It's a very bad example. Or for example, choosing only letter N and A, only 2 letters. That's another bad example. It doesn't mean that I am representing the name of our pet. And you should avoid it at all costs. And don't make the mistake of thinking that you have a very strong memory. Sometimes you look back at your code as early as a day or 2 and you will have forgotten what your code really does. Okay? And in that case, you won't be able to do anything with your program because you don't understand what your code does. And most importantly, if you want to get employed as a programmer in a company, they will look at your code and they will also take a look at the naming of your data. And they will give you a score based on how well you are representing your data. In the next tutorial, we are going to learn about increment and decrement in programming. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kordi, and in this tutorial, we are going to learn about increment and decrement in Kotlin. So sometimes in programming, you may want to increment or decrement a value. How you can do that? We have a specific syntax for this specific task. So here, for example, I have a variable and this is my age and it is of type integer and initially it is 10. Okay, so now I want to increment this variable. How can I do that? I can say age plus assignment operator, notice this syntax here, plus assignment operator 2. So what does this code do here? It's gonna get the current value of the age variable. So for example, the current value of the age variable is 10, right? So the 10, and then it's gonna add 2 value to the current value of the age variable. So 10 plus 2 is 12, okay? So then after this operation is executed and the result is calculated, which is going to be number 12, it is going to assign the result to the age variable. So it is going to say age, assignment operator, 12. So now the current value of the age variable is 12. Okay, so here, for example, we have something called computer RAM. And I want to assign the value 16 to this variable. So now I'm going to increase the value of this variable. I'm going to say computer RAM plus assignment operator 16. Now, if I try to output the value of this variable to the console, let's see what happens. And let's run the app. So now we get the value of 32 outputted to the console. Okay, so we have the same syntax in order to decrement a value from a variable. So I can say computer RAM minus assignment operator, and then this time I can again choose 16. So if I try to output the value of this variable to the console here, you should see that the value 16 is going to be outputted to the console, number 16. And if I try to decrement this value again, I can say computer RAM minus assignment operator, for example, 8. Now let's see the result. So here you can see that I forgot to output this value to the console. So println computer RAM. Now let's run the app again. Now you should see that the value 8 is outputted to the console. So this is for incrementing and decrementing values. we have also the multiplication and division operations. So here I can say computer RAM, multiplication operator, assignment operator, 2. So now if I try to output this variable or the value of this variable to the console, you should see the value 16 is going to be outputted here. I can also show you the division operation. So computer RAM, division operator, assignment operator, and then for example 2. So now let's try to output this value to the console. Let's run the app. Now you can see number 8 outputted here. So this is for incrementing, decrementing, multiplication, and division. Hopefully that makes sense. So the final operator that I want to talk about here is the plus plus operator. So for example, I can say computer RAM plus plus. And now you should see that the current value of this computer RAM is 8. And when I say computer RAM plus plus, it means that it's gonna get the current value of the computer RAM. So currently it is 8, and it's gonna add only one value to this variable. So it is going to be 8 plus 1. So now if I try to output this variable to the console, you should see number 9 outputted to the console. So let's run the app and see the result. And here it is, number 9. And we also have minus minus operator. So I can say computer RAM minus minus. And if I say println computer RAM, again it's gonna output number 8 to the console. So the minus minus operator is going to decrement one value from the current value of the variable. So 9 minus 1, you can see number 8 outputted here. Hopefully that makes sense. So in the next video, we are going to learn about the section exercises that you should work on. I look forward to seeing you next. Hey, what's up everybody? This is Morteza Kurdi, and in this tutorial we are going to learn about the exercises and the key points of this section of the course. So your first exercise is to create a constant of type integer and initialize it. Make sure that you get the constant from a real-world concept. For example, the computer RAM can be a constant that we get from the real world. Your second exercise is to calculate the average of two numbers. For example, you can take number 10 and 20 and then calculate the average of these two numbers and output the result to the console. If you don't know how to calculate the average of two numbers, you can search online for this specific problem. So your third exercise is to create an integer variable and initialize it with an integer value. It can be any values. And then increment your integer value by 2, then subtract 10 values from it, and then multiply the result by 9, then divide the result by 4, and then shift the result to the right by 3, then increment the value by 1, then multiply the result by 2, and finally shift the result to the left by 4. Get the answer and output it to the console. So now let's learn about the key points of this chapter of this course. First of all, computers at their core only work with numbers and mathematics. A programming language allows us to write code that can be converted into instructions that the CPU can execute. Base 2 is the form of the numbers that the computers work with. Because this form consists of zeros and ones, and it's simple for computers to handle. We use comments in order to document our code. We use comments in order to explain a specific feature or code that we have written in our editor, so that later when we want to take a look at our code, or maybe someone else is taking a look at our code, they will understand what's going on. We can have a single line comment, multi-line comment, and nested comments. We use the println statement in order to output data to the console. The data can be represented as numbers and texts. We give name to our data so we can refer to it later in our code. We cannot change the value of a constant once it is initialized, but when we create a variable, we can change its value after it's initialized. Make sure to give your variables or constants a meaningful name so later you can understand what your code represents.